Today we're going to look at some applications of the law of sines and the law of cosines. And when we say applications, yes, these are word problems, but we're thinking about scenarios and context as well. So first, let's remember what the law of sines looks like. So the law of sines tells us about the ratio, between a side and the sine of its opposite angle. Is proportionate to the side and opposite angle of any side of any triangle. So again, this means that any pair of side and its opposite angle is going to have the same proportion in a given triangle. Remember, we can also think of these proportions as having the sine of the angle in the numerator and the side length in the denominator. Just remember that it's got to be consistent. If you have the sine in the denominator of one, it has to be in the denominator of its equivalent proportion. So when do we use the law of sines? Well, there are two cases where we should use the law of sines. Either we are given two sides, so two side lengths, and an angle that's not between them, or if we are given two angles and a side length that is not between them. So that's the real trick here, either two sides or two angles, and then another side or angle that's not between the ones that are given. Our law of cosines, this is the one that's a little bit trickier to remember because it's got a lot of pieces, but we can think of it as the length of a side squared. So again, the law of cosines applies to any triangle. So the square of a length of any side is equal to the sum of the squares of the other two sides minus 2 times those other two side lengths times the cosine of the angle opposite of the original side. Now remember that the label A, B, and C are pretty arbitrary, right? We could call any side A, B, or C, as long as we're consistent with having the two sides on the right hand side of that equation. When do we use the law of cosines? So we use the law of cosines when we are given all three sides, and then we have perhaps missing angles. So if we're given all three sides, then we can use the law of cosines. We can also use the law of cosines if we are given two sides and the angle that's between them. So when we are dealing with the law of cosines, we have to have at least two side lengths, so whether we have just two or we have all three. And if we only have two side lengths, we need to have an angle that's between them. If we have an angle that's not between them, then we use the law of sines. So as we look at these applications, we're going to practice a couple things. We're going to practice not only using the law of sines and cosines, but identifying opportunities to use them. So example 1, we have two fire towers, A and B. They are located 10 miles apart. They use the direction of the other tower as 0 degrees. And so rangers at fire tower A spot a fire at 42 degrees. Rangers at fire tower B spot the same fire at 64 degrees. So the question is, how far from tower A is the fire to the nearest tenth of a mile? So our distance right here is how far away from tower A is the fire. So what are we given here? We are given two angles and a side between them. So this looks like an opportunity to use the law of, it almost looks like an opportunity to use the law of cosines, except that the law of cosines says we have to have at least two side lengths, and we don't. But it doesn't quite fit our law of sines because it says we're given two angles and a side that is not between them. So how do we do this? Well, if we think about what we're given here, we are given 64 degrees, which is opposite of our unknown side, but we're also given a distance of 10, which is opposite of this third angle. Luckily, we can always find a missing angle if we have the other two, right? All angles inside a triangle add up to 180 degrees. So if we subtract our other angles, we get 74. So this angle here must be 74 degrees. And now this looks like an option to use the law of sines. So I'm going to set this up where I've got my missing side length, I'm going to call that x, over the sine of 64 degrees is equal to 10 over the sine of 74 degrees. So I want to get x all by itself. So I'm going to multiply both sides by the sine of 64. Remember, that's just a value. Oops, 64. And so on the left-hand side, we reduce just x left. So x is equal to 10 times the sine of 64 degrees divided by the sine of 74 degrees. And remember, you can use any scientific calculator here, either a handheld one or Desmos Scientific. Just make sure you are in degrees mode. And when you evaluate this, you get approximately 9.35, or to the nearest tenth, 9.4 miles. So this first example was a little bit tricky because it didn't seem to quite fit the criteria for our law of sines or our law of cosines. But knowing what we know about triangles and knowing the relationship between the angles allows us to set this up to use the law of sines. All right, question 2 here. This one's gonna take a little processing here. So 3 boats are at sea. Jenny 1, Jenny 2, and Jenny 3. Any Forrest Gump fans out there? Just shrimp boats all named Jenny. So the crew of Jenny 1 can see both Jenny 2 and Jenny 3. The angle between the lines of sight to Jenny 2, and the line of sight to Jenny 3 is 45 degrees. If the distance between Jenny 1 and 2 is 2 miles and the distance between Jenny 1 and 3 is 4 miles, what is the distance between Jenny 2 and Jenny 3? So that was a lot of information to take in. So I'm going to start by drawing a picture for myself. So I know it's a triangle. I've got 3 ships here, 3 boats. So I've got Jenny 1, Jenny 2, and Jenny 3. So it says the crew, we've got Jenny 1 can see both Jenny 2 and Jenny 3. Great. So the angle between the lines of sight to Jenny 2 and the line of sight to Jenny 3 is 45 degrees. So Jenny 1 can see both Jenny 2 and Jenny 3 with an angle of 45 degrees. Then it says the distance, between Jenny 1 and Jenny 2 is 2 miles, and the distance between Jenny 1 and Jenny 3 is 4 miles. And the question is, what is the distance between Jenny 2 and Jenny 3? So that is our unknown distance there. So when we're handling any of these applications or these word problems, it's really useful to take a moment to sketch a picture and really think about what the information is and how it's going to look. So now that we see that we're missing this side length between Jenny 3 and Jenny 2, we are given 2 sides and an angle between them. So if we're given 2 sides and an angle between them, we need to use the law of cosines. So I'm going to set this up as x squared is equal to 2 squared plus 4 squared minus 2 times 4 times cosine of 45 degrees. So remember, I set up x as being alone on the other side of the equation because the angle that I did have was its opposite angle. So that's why I know to put x on the opposite side of the equal sign. So I'm going to simplify this a bit. I got x squared. 2 squared plus 4 squared gives me, 4 plus 16 minus 16 cosine of 45 degrees. And remember, at any point, you could just put that left-hand side expression in your calculator, and it would evaluate to a value here. So I'm just doing a couple of steps in between. When I simplify that right-hand side, I'm going to get approximately 8.686. And then to get x all by itself, I want to square root both sides, and I'm going to get about 2.94 miles. So again, thinking about not just all the words, but making a picture and letting that picture really guide which law we're going to use based on the information that we're given. So one more example here, and this example I hope is going to tie a lot of different ideas together. So example 3, a triangular playground, has side lengths of 475 feet, 595 feet, and 401 feet. The question is, what are the measures of the angles between the sides to the nearest tenth of a degree? So we have a triangular playground. Again, I'm just going to start with a picture. And we know the side lengths are 475 feet, 595 feet, and whoops, not degrees, feet. Why didn't you tell me? And 401 feet. The question is, what are the measurements between, what are the measures of the angles, So now that I know that I have all three sides, having all three sides tells me I'm going to need to use the law of cosines. So I'm just going to give these some labels, A, B, and C, so that I can refer to those angles pretty clearly. And just going to go alphabetically here. I'm going to start with angle A. So I know the sides, and I have an opposite side, right? So when I set up this law of cosines to find angle A, I'm going to have 595 squared on the left-hand side of the equation, and then I'm going to have the sum of the squares of the other two sides on the right-hand side, minus 2 times 401 times 475 times the cosine of our unknown angle A. So this one's not going to be quite as straightforward with our calculator. We're going to have to do a couple of calculations along the way. 595 squared is 354,025. And then the sum of 401 squared and 475 squared is 386,426 minus 380,950 times cosine of A. Phew. So we want to isolate A, right? That's what we're looking at. We want to isolate A, so we need to start by isolating cosine of A. So I'm going to subtract 386,426 from both sides. So I will get negative 32,401 on the left-hand side. And then almost there, I'm going to divide both sides by negative 380,950. Now, again, I don't want to do too much rounding along the way. So when I rewrite this, I've canceled on that right-hand side, and I'm actually going to rewrite this a little bit. I'm going to put the cosine of A on the left-hand side just for my own visual there. On the to reduce that ratio there, a negative divided by a negative makes that positive. So I'm just going to keep this in its exact form there. Now it's positive exact form, and I'm going to use that in my calculation and try not to simplify it along the way. So we're almost there, right? We want to isolate A. So to get A by itself, we want to use the inverse cosine. So applying an inverse cosine, remember that's got that little exponent of -1. to both sides there. That is in our calculator. If you're using a handheld calculator, you're going to use second and hit the cosine button. So when I do that, I get a, whoops, that's not quite right, an angle measure of approximately 85.1 degrees. We are going to the nearest tenth of a degree. So I'm going to redraw my picture here just so I can scroll down and not have to go back and forth. But I'm going to add my new angle measure. Oops, degrees 401 and 595. So the question was, what are the angle measures of all three angles? Well, I've got one angle right now. I need two more. So I'm going to look at angle C here. I know I'm not going alphabetical order. You can try to find angle B, and then we can check and make sure we've got all three of them the same at the end, whatever you want to do. So when I think about this, I have all three sides, and obviously I could use the law of cosines like I just did here. Alternatively, I can think about the fact that now I have this missing angle, and I know its opposite side length. I know another angle and its opposite side length. So I could also use the law of sines here. And since the law of sines is slightly fewer steps than the law of cosines, I think that's the route I'm going to take. However, you could obviously do this using the law of cosines as well. And if that's something you're interested in checking out, I encourage you to do that. So I'm going to set this up as the sine of C divided by 475 is equal to the sine of 85.1 divided by 595. So again, I'm trying to find my measure of angle C. So I need to isolate sine of C. I'm going to do that by multiplying both sides by 475. Whoops. How many times does it take me to write 475? There we go. So the left-hand side will reduce to sine of C. And on the right-hand side, I'm going to try to keep this as exact as possible until the very last minute. And so just like we did to find the measure of angle A, if we're going to isolate C, the measure of angle C, we need to apply an inverse sine to both sides. So I'm going to apply inverse sine to both sides. That's a little smushed here. So let me rewrite that. So C will be equal to the inverse sine of 475 times sine of 85.1 degrees divided by 595. And again, for precision, I want to keep that all together until I'm ready to put it in my calculator. And when I do that, I'm going to get approximately 52.7 degrees. So I'm almost there. I've got my measure of angle C, 52.7 degrees. And now I need one more angle measure. I need the measure of angle B. Now I've shown I can use the law of cosines or I can use the law of sines to figure out angle B. However, I have 2 of 3 angles in my triangle. I think I'm going to use what I already know about my relationships between the measures of angles. So that means that angle B is equal to 180 degrees minus the measure of angle A, 85.1, minus the measure of angle C, 52.7. That means that the measure of angle B is going to be equal to approximately 42.2 degrees. So what I really like about this example is that it kind of really gives us some good practice looking at what information are we given about the triangle, and how do we use either the law of sines or the law of cosines to figure that out. So go ahead and check out your practice assignment. If you need some reminders about the law of sines or the law of cosines, you can always go back to last week's work, or you can reach out to me, email, Canvas, whatever you need. So hang in there. You are almost done. You've got this and you've been doing a great job. All right. I miss you. Hang in there. Stay amazing.